Let's try to learn some of the examples to change the data types in C++. So we will have different data types and we will convert within C++. So let's begin by writing the hashtag, and we will say include, and then we have this IOSTREAM. Then we will say using namespace. Then after we will have std semicolon. We will say the class base. Then we will write virtual. And this is our void func. Parenthesis close. Here we have the curly brackets. Then we have the semicolon at the very end. Then we have the class derived. So we will try to see what this code will do at the very end. And public base. And open and closing of the curly brackets. Then we have our intmain, and we will have some major types of the data conversion. So the first one is the implicit, that is IMPLICIT. And this is conversion. Here we have integer a as, let's say, 20. And then we will say float, float, b is equal to a. So this is a type of, let's say, implicit. So implicit conversion from int to float, float. So this is our first type of conversion. Then we want to print this COUT, some operator sign. Then our string here, implicit conversion. We will say here int to float. And then we will give here some more operators. Then we will say int L. And this is our first type of conversion. We will run this at the very end. Then we have the explicit type of explicit, that is EXPLICIT. This is an explicit type of conversion. So we'll say here double and C with the value. So this contains some decimals and the values. So this will be int, then we will do, it has integer, it's int, and then we'll keep inside this as inside C. And this is called the C style cast, where we do double to integer. And for the quick operation, we'll copy this and paste it here. And I'll say this as the explicit from, so we are doing here double to integer, let's say double, double to int, and the value is d. So this was the second type of the conversion. And then we also have the static cast, where we say float, and then E is equal to static. So we are suggested here, somewhere here it is the static cast. And then we do float float, and then provide this variable that is A. And let me paste this print function again. So this is the static cast, where we are doing integer to float, and then we have the E at the very end because we want to print the E. So this is the explicit conversion, but this is one of the type of explicit. And then we have the dynamic cast. So this is the dynamic cast. So this has been used with polymer fission. And here we do the BAS, and then BASEPTR, name WRIVED, and then we will say DERR. It should not be capital, derived. Then we say DERIVED, capital PTR. Then we have the dynamic cast, and then we say DERIVED. Here this should be capital, and then DERIVED, and we say BASEPTR. And the next line will have some ifs going on. So if derived PTR, then after this exclamation mark is NULLPTR, then we will have something here. So we will print dynamic cast. So let me change the string here. So we will have something printed that this will say dynamic cast, SUCCESS, success. And we are going to only print this one, and we're just not going to print anything else. But we also have the other condition where we will say else we will have else. So this should be closed because this is open here, and this should be closed. So, and then we have the else, and the else is something different, and where we will say else. So let me copy this again and just paste it here. And then we will have dynamic cast filled and filled. So the other information would be to say successfully casted guess to derived. Filled, this would be casted to derived. Then we have the other one, that is the constant cast example. CONST CAST, and this is also the next example where we remove const QALIFIER. And here we will keep some constant. This is constant int f is equal to 100, and then int ptr CNST const. So there's a function already there. Constant const int. Then we will say end. So we will require some of this end here, and then we'll do f. And what it does, it will remove. So this is a comment. Remove const qualifier. This is the one, and then in the next line we'll have ptr is equal to 200, and this will modify the values. Modify the values, and then we will print something. We will print something here. This will say on CAST removing CAST. And what we're doing here is we are printing ptr l, and then the final one is to reinterpret REINT ERPRIT, reinterpret cast example. So this is CAST, and the spelling of example. This is to convert the pointer type. And here we do int g is equal to the 10, and then int. Then we have the int ptr is equal to end c, and then void, then void ptr is equal to rein reinterpret cast. This is the one we need, and then void. Then we have the int ptr. Then we will do COUT. Then reinterpret cast to void, right? Then we will print here void ptr, and then d l, and then we will finally return the 0. And we are seeing some problems here, and this is probably because we might not have done something nicely, and I think this is extra here, if that's what we should do. And we're still getting the problems, it's 2, so it says line 36 in the column 31. There's something else we haven't done. Is this the one we need? Okay, this is not the one thing we need. So there's something expected a brackets. So we have done something here. So let's see. Best, we did best. And then we, in the second line, we have derived. Then we have the dynamic cast. Then we have if derived PTR equal to this operator here, and then no PTR, and then we printed something, and else. So it's expected in the line 36. So line 36. And here we have the constant to the f equal to 100, int PTR equal to constant cost, int. So I think this should be inside here and outside. So, and then we don't have problem now. Let's do what we need to do is C++, and then we just give a space, and then we, oh, first we need to save this as Ctrl+S. Then now we have the file name, and then we do the tab here, and then we enter this, and we are created with something here, like we get this a.exe file, and what we do is a// it's .a and tab. Oops, I might have forgotten that one. What is that? .a, I keep on forgetting this one. No, that is .a. I'm very ashamed of myself for this one because I had learned it previously. I just forgot it. It is .a// or what is it? .a. Or I can say I just need to click here. I think I just got myself ashamed here. Let me search somewhere. I forgot that. And that we have okay, that is, I had remembered this one, but this, what we need to do is .a and slash, no, .a / no, .a, okay, we just need to do .a and / I keep on forgetting this one. And this time it is not working in .a. So ./a, .a, .a, ./a, okay. Okay, now we got the some result here, and what you need to do is .a, / and a. Okay. this is the result here. So I am ashamed of myself for forgetting this. I need to write this somewhere. I had memorized this one, but I keep forgetting to type A first or A last. Okay, A. What slash A tab. Okay, this is the result here. And so we have, okay, now I want to read the notes for the data type conversion. So let's try to understand a few of them. So in C++, the data types are changed by two ways. The first one is the implicit conversion, and the second one is the explicit conversion. And the explicit conversion are also called casting, and the implicit conversion are also called as the coercion type or the promotion type. So the implicit conversion is when we assign a value of one data type to another. For instance, we want to assign an integer to a float. So the C++ will automatically convert the integer to the float. And this is happening here. So we first created this variable A, but this was stored again as float. So this just happens. We just need to assign this one as the float, and this will do the task. So the converting an integer to a float is okay, and it does not lose any precision in most of the cases. But if there's a decimals, we're going to lose the values. And the next one is the explicit conversion. So there are many types of this method. And in this case, we need to manually convert between the two data types. And this is called the casting. And we have different ways to do this. The first one is the C style casting. And in the C style casting, we cast a variable to another type using the parentheses. So this is an example here. We are assigning this double variable that is 1.11 to the D. And then we also have the C++ style casting, which is more explicit of the casting compared to C style cast, where we have the static underscore cast. And this is used for most conversions, like converting between numeric types. We have static underscore cast, and we see this as with a float. And this is converting integer to float. Then we have the dynamic cast. This is used for safely converting pointers or references in class hierarchies. And this is when we use the polymorphism. And then there's also this const underscore cast, and then new type of then const underscore cast, the new type, and then we do the expression. So this is used to add or remove constant qualifiers. And there's also this one, the final one. This is the reinterpret underscore cast. This is used for low-level casting for the pointer types. So to basically summarize, the implicit conversion automatically converts an integer to a float. Then there's the C-style cast, which explicitly converts a double to an integer, which just removes the decimal part. And the static cast is where we safely cast an integer to a float. Then we have the dynamic cast, which casts the best to derived kind of thing. And this is used in the polymorphism. And then we have the const underscore cast that removes the constant qualifier from a constant variable. And This is also allows modifying the value through a pointer. Then we have the reinterpret cast, which converts the integer to a void and which can later be cast back if needed. And we saw the result. Result was implicit conversion, and some of its results here as like that. And we will keep learning, and that's all.